I started tearing down Mr. Wright's Probe GT engine, and most of these were not necessarily loose, but not tight. And this is the inside of the PAM, so I don't know. This is still kind of a mystery. Like a lot of this, I don't know the history of the engine. Supposedly it was built, quote unquote, by another shop 7 to 10 years ago, but I don't know what level of build they did. You know, I don't see any ARP hardware, still the factory rods, presumably also factory pistons. I did track down some forged rods and forged pistons, but I don't really know what we're going to be up against until I take it fully apart. But I'm going to inspect all the bearings, the crank, and all that other stuff. I mean, you can see right off the bat, look at that. So that's metal. That little spot there I swiped with my finger earlier, and it looked like swiping a drain plug in a transmission case. So I'm going to keep stripping it down and see what more I find. Mismatch bolt on the oil pickup tube. I'll fix that on reassembly. I mean, this was supposedly built by a shop who does imports on and off. Tell me you don't have any matching 10mm bolts laying around? Come on. And so far, these rods don't look terrible. So that's 5, and that's 6. I mean, I'm not really seeing where all this nasty sludge and metal is coming from unless it just wasn't a clean engine build. And what I mean by clean is they just let whatever dirt was in the system and during assembly and whatever just stay. We got some gouging on this piston here. So cylinder number 5, the piston skirt's got a gouge in it. Not the worst I've seen. All right, let's flip this thing back over, and we got to pop this oil pump off. I don't know if y'all saw that crank spin. Look, I can spin it by the gear. That's usually that's what you want on an assembled engine. You want little to no friction. So it's probably a good sign as far as the condition of the crankshaft. Now this is going to be the fun part, getting this damn pulley off that doesn't have any removable. I hope I don't have to cut this thing off. You got some movement out of it. You know, I don't know what backwoods engineer thought that putting a slip-on crank gear with no bolt holes in it to use a puller to get it out. I want to meet that idiot. Kick him right in the nuts. It seems to be a common Japanese thing. I don't know what the hell's the matter with him. It's such a stupid, simple solution. Engineers would walk barefoot through coals and broken glass to screw over a technician. Crank keyway is out. What do you want to bet this thing is still? Yep. Fixed in there. This is why Mazda is not as big in the US anymore as they used to be. And they deserve every bit of it. 100% of it. This stupid shit. And it's not just Mazda that does it. Nissan does it too. There's a reason they're failing in the US right now too. Now that I am no longer raging at Mazda's fine engineering, let's pop this oil pump off and maybe pop this crankshaft out. Jeez. Those are gonna be fun to remove. These are probably torque to yield. They sound like it. Or they just broke off in the block. I don't think so. There's one missing here, guys. Or did it come off with the, Okay, no, it's not missing, is it? Yeah, dude. The very last crank girdle bolt is missing. Never got put back in. I can't imagine the probe community is very big, especially the kind of people willing to sink this kind of money into a probe GT. More than likely at some point, whoever had their hands in here is probably watching this. You left out one of the main girdle bolts. You're kind of a piece of shit because there's no excuse. Absolutely no excuse. That is a main structural component. Ooh, you know what? I think we got a broken bolt in there. That's why it's missing, because somebody probably tried to... Oh, dude. We got broken bolts. I bet somebody tried to reuse these torque to yield bolts. I'd almost be willing to bet. Just when you think you've seen it all. So this is one of the bolts that popped on me. Look at that. That's how I removed it from the bore. Isn't that cute? And it was missing a washer. Dude, whoever worked on this thing, man, sloppy. Sloppy, yep, broken bolt. Yeah, if you worked on this thing and you're watching this video, dude, you need to put your tools away. Give up. Because this ain't for you, bud. Okay, so on number 1 main, no broken bolts. Oh, 1 broken bolt on number 1 main. On number 2 main, no broken bolt, missing washer. No broken bolt, missing washer. Number 3 main, no broken bolt. Broken bolt and missing washer. Number 4 main, not broken bolt, but missing a washer and rusted. And completely missing, probably broken off in the block, and they were like, screw it, not my job. Wow. Well, Austin, if you're watching this, at least you know that I'm not bullshitting you, that it's actually going to get done properly. Yeah, unbelievable. know, I'm still not really 100% sure why there was so much metal in the pan. Unless this thing was just starting to fail and the best case scenario for him was the head gasket blowing. Because they don't really look that bad. I mean, I've seen a lot worse, but dude, there's a ton of metal in this thing. I don't know. Wasn't built right, but we're gonna build it right. I'm working on trying to track down an oil pump. Here's that broken bolt I mentioned. It's broken off in the block. That was exactly how we found it. All of these bolts are torque to yield, and Ford has long since discontinued them. I have not been able to find any on eBay, so I was able to cross-reference a Mazda part book, because this is technically the same engine family that went in the Mazda 626, the 323, I believe, as well. It's the KL engine series from Mazda. So there are some crossovers to the Mazda side where I can maybe get some replacement parts. So I'm gonna have to go up to the Mazda dealer probably tomorrow morning and see if they can show me a parts diagram and we can pick and choose all the different bolts I need. And I'm hoping that I can get all of the bolts, because if not, this is gonna slowly become a nightmare. I think I got lucky and was able to track down all of these bolts and all of these bolts through a Japanese source for a Mazda 626 or Millennia, MX-6. There's several platforms that got this 2.5 liter. I was able to track down a factory oil pump and a factory crank sprocket, all Mazda parts. Ford has long discontinued all this stuff. So we spoke with Austin today. We're gonna move forward with the Ford's pistons, the Ford's rods. I'm getting ready to mic the crank right now. I just, you know, apparently all of my batteries and my mid-oil calipers are dead, so that's real cool. But I'm gonna mic the crank, I'm gonna document everything. I'm also gonna inspect the piston bores. The rods, for the most part, pretty damn close. They're all right alongside each other. Not very much variance there. There's a little bit more variance in the main bearing measurements. But you can see there's such a wide degree of tolerance here from the factory that, you know, it's all considered good. So we're gonna do our best to get it as close as possible. I think ideally when you blueprint an engine, you try to get it, get the degree of tolerance within 1,000th or a 0.5,000th of each other, so all of your clearances. So in theory, if all of your clearances are damn near exact, you have the same amount of friction across all of those bearing surfaces as well. So one side's not wearing more than the other, one side's not robbing power more than the other, and so on and so forth. So crank is measured now, so it's good to get tagged and go to the machine shop. I'm gonna jam the main cap girdle just tight enough to go to the machine shop and let them know that it's gonna have to be torqued to spec to bore the cylinders. The next goal is here. I've got a bore size spec for the cylinders. So what I'm gonna do is I'm just gonna set the 0 point at like 3.33, just to keep it simple. It's just a nice round number. What I'm gonna do is set my micrometer to that size, chuck it up in the vise, and then I have a dial bore gauge that I'm going to dial in and zero out at that exact distance. And so this will make more sense once I actually get it out of the case and I show you a visual example. But basically the dial bore gauge is going to measure the inside diameter at its largest point. And so if I zero the dial bore gauge to 3.33 inches, that means if it reads 1,000th above or 1,000th below, that's the true size of the hole, so I can work backwards off of that. So I'm gonna gauge all the bores real quick, check for taper, and see where my size is so that I know exactly what size pistons I need to order, because we're going forged pistons and I need to determine if we can keep the factory size or if we need to do an overbore. Okay, so first important step of doing any type of precise measurement is you want to use, I think these are called plug gauges, I forget, not plug gauges, this is true 3 inches, okay, it's calibrated 3 inch, piece there, so I can get the camera to focus. And if you look at my measurement, the hash mark here for 0 should have lined up with the 0 mark there. So since it doesn't, what I'm going to do is there's a small wrench that you use to calibrate the scale, and you pull it back into spec. So I'm going to do that so that whenever I put this 3-inch rod in my micrometer, it reads true 3 inches, not 2.9995 or whatever that's reading right now. So you always want to zero your equipment. If you don't start with this, everything's going to be off. That is pretty damn close. It's really hard to get it exact, but for the scale that we're measuring at, that little slight difference, we'll just chuck it up into the plus or minus. Alright, so is this starting to kind of make sense, guys? I have my micrometer chucked up in a vise, and now I'm gonna set my 0 point. Actually, I saw something online. Let me try it this way. The hardest part is actually getting this thing in where it needs to go to zero it. It's even harder to try to do this on film. If you're a machinist or engine builder, let me know in the comments what you guys do to get your dial bore gauges zeroed in. I feel like I'm doing it the hard way and trying to get my 0 point. And I've tried all kinds of things. I set it on the bench. So let's see what these piston bores are at. I zeroed it at 3.325. Should probably clean the bores. Don't want any trash in there. I forgot to turn the camera on, but I found a piston bore measurement sheet. I grabbed a piston bore measurement sheet, and this is just kind of a universal one you can get free online. I downloaded from some college. And, you know, this one wants 4, but I don't have that many points, so I'm just kind of splitting them in thirds. So I do it 1/3, 2/3, all the way down to the bottom, and I'm grabbing my measurements that way. So I'm going to make the A plane facing front to back and the B plane horizontal. Alright, so we got some bore tapers to measure. At least I have a baseline. Let me do some maths. Okay. We're going to work on assembly now. So we got a completely stripped block. Fresh from the machine shop. This particular block I'm working on is going to be a 3.2 liter stroker. I have already sonic tested this block. It's got plenty of wall thickness. It's going to be a non-turbocharged vehicle. So we're well within the specifications to handle that. This one's actually going to be for Mr. Wisniewski's 240Z. So 3.2 liter stroker. CNC ported N42 head from L-Spec Datsun that we did all the final assembly and head work on. It's getting a Schneider 292F camshaft. So right now I'm just going to work on cleaning up the block. I am going to have to notch it for the stroker rods. So I'm going to get it cleaned up enough to set the crank in temporarily and measure where the rods are going to hit the inside of the block. And I'm going to work on clearancing all that. The other stroker I assembled already. I had the machine shop do this. But if you're doing a home-built stroker or just want to see what it would be like if you decided to do it yourself, I sort of saved this engine build for it. So you can kind of see what you're looking at, and you can make a decision on whether you want to take this on yourself or you want to pay a machine shop to do it. For time and consistency, I would recommend paying a machine shop to do this. Okay, so basically what we're trying to achieve is just get it temporarily in so we can check the geometry. That's close. So this is what I'm after here. If you look at how tight that clearance is, it is not hitting right now, but it's real tight. So what I need to do is measure the clearance there and figure out how much is our spec. I'm almost certain that it is, you want like a 60 thousandths minimum clearance or something like that. But yeah, so that's what we're after. Anywhere that it either contacts or gets way too close, we're gonna clearance. 60 to 80 thousandths is the clearance that we're targeting. Just doing an eyeball measurement, it looks like we got less than that. But I'm going to put a feeler gauge in there. Alright, well, I guess I'm going to have to make my own. Alright, so we'll go with 70 thousandths. Yeah, and it's definitely tight. So. Kind of show y'all where I'm gonna have to clearance. So I marked with paint marker all the areas that the rods came real close to hitting the block. Now this area in particular, you'll notice there's an oil galley that goes right through here. So I don't want to get overzealous across these three. Once I get past these three, luckily I have quite a bit of clearance here. You can see it's rounded here versus it's a flat edge there. I've got to smooth out that edge and make it more even transition. There's no oil galley here. It's only for the first 4 mains, and then the oil pickup tube comes here. After the oil pickup tube, there's no need. So those I can just take off as much material as I need. So let's get started. If you don't have one of these Milwaukee straight grinders, die grinders, you can also get it with an angle grinder as a set. These come in clutch. Port work, grinding out things, block work. They're definitely worth the money. All right, let's see how filthy I can get. So there's my notch mark, and if I grab it's kind of the theory that I was working with is if I should do it the width of a feeler gauge, it's hard to do on camera, but if I rake my finger across here, it's about level, or just under being level, which means that I'm just north of about 60 thousandths. See why I taped all the holes? So the last thing you want is to be dealing with all these fine metal shavings. But got all of our notches here. I started working on the very last one, and the tool overheated. I'm about to give it a little bit of a break. We got those 2 notches, and I think since I'm here and I've already got this thing covered in metal, I'm going to go ahead and grind away all this casting flash. That's another common potential failure point on these L series is these little chunks of casting flash can actually break off. And, you know, you break off a little small chunk of cast iron, it gets sucked up into the pickup tube, you're eating an engine. So on something that's going to be turning super high RPMs or even just excessive load, like the turbo stroker over there, we cut away all the casting flash, and we're doing the same thing here on this one. I'm going to take a water break while the die grinder is cooling down, and we'll get back to it. Okay, after lots of grinding, got all of my notches in the block. You can see here, this one, we got plenty of clearance. I can fit an 80 thousandths feeler gauge in there with no issue. So I'm just going to work down the line and check every single one. And then also all of the casting flash, you can see now that it's fresh, where it's all been ground down. Just areas where you can get, you know, sand impregnated in your block or metal, old dirt, whatever, just areas that can hold stuff you don't want circulating in your engine block, or areas that can break off under high RPM and vibration. So I got rid of as much of it as I could see. Anything that looked like a potential threat has been ground down or ground away. And this one was like heavily, lots of, you know, lots of sand mold stuff. So I ground all that away so we have a smooth surface that doesn't accumulate stuff. So I'm gonna, like I said, I'm gonna check every single chunk now. And then we're gonna get this thing completely cleaned and ready for measurement and final assembly.
We're not looking at the Hawko today. We're looking at this 280Z. It's been in the parking lot for a long time, waiting for Bo to take it apart. How'd you pull the radio out without?
You notice how there's holes?
Is the top of the console broken?
No, just look at it.
That's supposed to be.
I mean,
all right, Bo. Look,
yes,
that's supposed to be solid right there.
Yes, but no. Yeah, they screwed it in.
As you do.
Yeah.
Yeah, that's cool.
Yeah.
Well, he's got this nice speaker box and a camera platform if you want to vlog in here.
Well, I'm done inside.
Oh, you're done? Okay, cool. That's cool. Yeah. This will soon look completely different, and we'll have a bunch of cool race car parts on it. Motors over here. I'm sure we've filmed it a lot, but Note Fab intake, GT30 external gate, question mark. Yeah, it look good. Oh, it's a board, not a GT30,
yeah,
I forgot.
Yeah. I think they said it was a S650 or something.
S650 question mark?
S200 SX, whatever that is.
Whatever that is, 200
I don't
SX?
know Borg Warners.
200 SX? It's a Nissan?
I don't know Borg Warner. I'm a Garrett boy.
Yeah. I like how you put this rail on with no injectors.
Yeah, they're not. They're very loosely in. I just want to make sure that they were lined up.
Where are the injectors at?
On the way.
Why are they not here?
They ordered the wrong height. Because we didn't have this.
That's true. Yeah. Okay. Yeah, my fault. My fault.
Alright, back on Morse's latest update. Basically ready to pull engine, trans, get it open. About to pull the trans right now. Got drive shaft out, sway bar out, so I can get to the bolts. Yeah, just gonna set it up for time lapse and let y'all see me pull it out. That's how you get an engine out. So we'll go ahead and swap over like alternator, anything that we need, like front cover, block off plates, clutch, swap over everything we need, motor mount. And we'll get ready to stuff her back in with that one over there.
Bo yesterday got a bunch of the bushings blasted, or at least he got the mustache bar bushings blown out. Now he's gonna do the lower control arm bushings. Or actually, no, we're good to apex arms, so just the mustache bar bushings got blasted out. He got coilovers welded on. There's just the struts themselves. There's the coilovers. Yeah, when I weld that, it does not look like that. It looks like ass. Yeah. That's what Bo did yesterday. Bo is over here still doing turbo stuff. He welded the drain plug, or the drain into the pan. So now we're gonna go out of the turbo, around the wastegate, straight in. So that's getting close. Hopefully that'll be in the car, maybe today? Question mark? I don't know, bro. We'll see.
Alright. Ready to put Morse's engine in. Got it all situated. The oil drain. Put a V-band on, because I knew that would be a lot more difficult in frame. Still gotta fill this hole. Always remember to check that thing. Yeah, just gonna set it up. Get it ready to put in. Alright, well, camera died, but engine in. Looking good. Milk fab does point like straight for the hole that's right here. That is nice. Hard to see, but turbo down there. Yep, coming along. Ratchet strap is the goated idea. If you don't, these engines lean back very bad. It just puts a lot of strain on the motor mounts. So the way we do it is we always just hook it, keep it from falling back all the way. We also do this when we pull the trans out. That way it doesn't just fall whenever we pull the trans out. But yeah, today trans will be back in. Possibly the whole rear end. Possibly. I need to do the fuel system first because it's all open. But yeah, lots of progress. Going pretty smooth. Going relatively fast. Yeah. Keep you up with the next update.
Brand new old ass turbo. Got this thing rebuilt. This is Bozo's old turbo off his 280Z. He sold to our customer, like Nguyen. This was a good turbo, just needed to get ran through. So you compare that to his old one, which is actually a 50-year-old turbo. I'm gonna wiggle the impeller a little bit. Let me turn the light on. Yep. That's no good. It is no good. So it was smoking a little bit, and you could also hear it while driving. So I got the intake manifold off, got the exhaust manifold off, about to swap that out. And then like Nguyen's car will be back on the road and boosting as it should. Well, my Nguyen's car is on the lift still. I did the whole turbo swap thing, and I conveniently didn't film any of it, so that's cool. But brand new turbo in there. We drove it to lunch today. It actually makes spool noises now. The old turbo didn't really make spool noises. You just heard like a noise. It was like it was weird. But this one sounds like an actual spool, and you can actually hear the intake through the air filter. Sounds cool. Currently have the gas tank out, and while I have the gas tank out, I'm going one of the bumper shocks removed, which is a lot more annoying than I thought it was going to be. Not gonna lie, it was pretty ass, but I also don't own an S30, so there's that. But there's the shocks. You're supposed to take the interior apart a little bit because there's 3 studs that go on each side, 3 studs that go up, and then 3 bolts that go down. So yeah, that was fun. We're putting an S30 World tank in the car, and I actually encountered my first fitment issue on these gas tanks. So there's a little tab right there that is the locator for the sending unit, and so it has the lock in right there. It didn't quite fit right, so the tab on this one was straight, whereas on the old gas tank it's bent down, and then it's like this, not straight. It's kind of like that. It has a lip on it, so I had to match that. So you can see how that tab is right there. And this shape is also a bit different, as long as it seals, I guess, but we'll find out. I'm not 100% sure if it's going to seal or not. But there's that. It's in there. It's locked in. This tank is, that's the first time I've ever had an issue. I think this is my first time installing the late model gas tank as well. These fittings are also at a slightly different angle. I think these are closer together on this tank, and on the old one they're further away. Not a huge deal, but I mean, you can see that this is a rather aggressive intersection. My truck is in here because I put a new orifice tube in the AC system, and when I turn the AC on, it goes for like 10 seconds, so that was annoying. I don't know if I ever put in the vlog, but damn, orange. I bought another set of calipers and powder coated them orange here instead of the purple I used to have, which are up there. Purple. Yeah, that's it. It's hot outside. It's June, so it's that time of year where everything's just ass. Days are ass. Hot. Nothing gets done. Yippee. I tried to, this was my Nguyen's old collector boot thing. It was already split in half before I tried to take it off. I mean, like, yeah, garbage. So we got a new coupler for him. I was gonna take this one off, but I mean, that one's just as bad. So he got a new one. Sorry, Mr. Nguyen. Cost more money.
We are closing out June 2025. I have been in Canada for the last couple of weeks, and I got back last week just in time to close out the end of the month. Let's see what we got going on here. Bo put a turbo guard on his turbo and solved a starving for air problem. So this car, I haven't ridden in it yet, but supposedly it's a totally different car now. We're backlogged on the Hako Skyline. We got the speed hut gauges in and the TL70 in, but we're working on some different shifter arrangements with Derek over at Dotson Works, so we don't have to cut the trans tunnel at all, or the shifter opening. So working on that, so that project's kind of in limbo. So during that, Bo has been focusing on Mr. Higgins' painless harness job. But after those two are completed, or at least movable, we're gonna move on to finally starting the 5-liter swap in that Ranger. Mr. Burns' truck, we attempted to put some Z32 injectors in it, but they're a different style injector and it leaked fuel in the factory BG33 fuel rail. So then we tried ordering Z32 fuel rails. They didn't fit. They hit the intake manifold, and as of right now, I've got Paulnet helping me out with a redesigned set of brackets for our Z31 fuel rails to work with the BG33 lower intake manifold. That's the current holdup on that. We're gonna run a set of EV6 injectors and finish that off. Don't forget to hit that like button, subscribe, set the notifications so that you get a pop-up notification every time we make a new video. That's totally free. It doesn't cost you any money to do that, and it helps support our channel and helps us to continue to grow. Now that we're monetized, we're really trying to grow our channel to where we can invest in better technology for filming and everything. So thank you all for watching our channel and supporting us. As always, don't forget to check out our Amazon store. We got lots of goodies on our Amazon store, product support, material, media, things like that. Don't snooze on our eBay store. We're constantly getting used parts listed, sometimes new parts that we ordered that were incorrect, and by the time we realized it was too late to return them to the vendors, so open box specials, things like that. You can find a really good deal on our eBay store. Don't forget about our merch. Buy our t-shirts, our coffee mugs, glassware, help us with our brand recognition, hats, all that stuff. Every little bit helps. And other than that, thanks for sticking with us through June 2025. We appreciate you guys watching, and we'll see you next month.